Self-practice 5.1. Questions number 1. Find the common difference for each of the following arithmetic progression and state the methods to obtain the arithmetic progressions. So the constant difference of an arithmetic progressions is the difference between any two consecutive terms, which is a constant value. So for questions A, you can find the common difference. So here I use D1 for if you are using negative 31 and negative 21. So this is the two consecutive terms, so we are going to minus them. So here you're going to get negative 21 plus 35, which is equal to 14. Or you can also find the common difference using negative 21 and negative 7. So here I can use negative 7 minus the previous term, which is negative 21. So here it will be negative 7 plus 21, which is equal to 14 as well. So the method to obtain the arithmetic progression is you are adding a constant value, which is the 14, to the previous terms. Questions B. So this arithmetic progression involving the surds. So first, to find the common difference, so first I'm going to use 5 surds 3 minus the 2 surds 3. As this is the common, is the similar surds, so I can minus them together. So this will give you the answer of 3 surds 3. The other one is that you can also find the common difference using 8 surds 3 minus the 5 surds 3. So this one will give you the same answer as 3 surds 3. So the method to obtain this arithmetic progression is that you are adding 3 surds 3 to the previous terms. Question C. So the terms of the arithmetic progression say involving the algebra. So the same thing, if you want to find the common difference, just find the difference between two consecutive terms. So here I'm going to use first using 2p minus bracket, so I'm going to minus the whole thing, p plus q. So this is the same as 2p minus p minus q. So here, solve for the like term, you're going to get p minus q. Or you can also find the common difference using 3p minus q minus 2p. So here, solve for the similar the like term, 3p minus 2p, which is p then minus q. So the method to get this arithmetic progression is that you are adding p minus q to the previous terms. Questions D. The arithmetic progression involving the logarithm. So first, to find the common difference, the first one I'm going to use log base a of 2 to the power of 4 minus log base a of 2. Now these two log are of the same base. Now using the division law, this will be log base a of 2 to the power of 4 divided by 2. So here it's going to give you the answer of 2 to the power of 3. Next, you can also find the common difference using log base a of 2 to the power of 7 minus log base a of 2 to the power of 4. Again, using the division law, this will be 2 to the power of 7 divided by 2 to the power of 4. So here the power after you cancel it is going to be log base a of 2 to the power of 3. So the method to obtain this arithmetic progression is that you are adding log base a of 2 to the power of 3 to the previous term. Questions number 2. Determine whether each of the following sequence is an arithmetic progression and give you justifications. So to determine whether a sequence is an arithmetic progression, you need to make sure the difference between any two consecutive terms is a constant value, which is known as the common difference. So if you look at the sequence in questions A, the difference between two terms will be, so from 9 to 13 is you are adding 4. From 13 to 17 you are adding 4 as well, and go on. As you are adding a constant value, which is a positive 4 to the previous number, therefore questions A is an arithmetic progression. As for questions B, if you find the difference between the two consecutive terms, so here you can use 1 over 4 minus 1 over 2, you will find that the answer is equal to negative 1 over 4. And if you continue using 1 over 6 minus 1 over 4, you will find that the answer is negative 1 over 12. Now, if you look at the difference between these two consecutive terms, they are different. They are not a constant value. Therefore, for questions B, this sequence is not an arithmetic progression. Question C. So now, first thing, find the difference between these two consecutive terms. 0.01 minus 0.1. You'll find that the answer is negative 0.09. And for these two consecutive terms, 0.001 minus 0.01, the answer will be negative 0.009. So these two differences, they are different to each other. They are not a constant value. Therefore, for question C, this sequence is not an arithmetic progression. Questions D. So first, we're going to find the difference between the two consecutive terms. So here you can use number 5 minus the 5 minus x. So here I need to put a bracket because I am minus the whole thing here. So this will become 5 minus 5 plus x, which is equal to x. Now, if you use another two consecutive terms here, it's going to be 5 plus x minus 5. So my 5 minus 5 here will be cancelled. Therefore, the answer it will be just x. So the difference between the two consecutive terms here, they are the same, which is the x constant value. Therefore, for questions D, this sequence is an arithmetic progression. Questions number 3. Complete the network diagram below, given that the relationship of each of the following network is a consecutive terms in an arithmetic progression. So first, for questions A, I'm going to look at this vertical sequence. So if you look at this vertical sequence from bottom to the top, the number is getting bigger. So the difference between 10 and 8 is 2, and you have another terms in the middle. So I'm going to divide the number 2 by 2. Therefore, the difference between each term is you are adding 1 to the previous terms. Therefore, the terms at the middle here will be 8 plus 1, which is equal to 9. Now, if you look at the horizontal sequence here from left to right, here you are adding 4 to the previous term. So 5 plus 4, you get 9. So as this is an arithmetic progression, so here we're going to repeat the same thing. So 9 plus 4, you will get the terms equal to 13. Questions B. So I'm going to start from here. Now, if you look at this sequence, using this from these positions, from 2p to 12p, this is getting bigger. So 12p divided by 2, you will get the difference is 10p. So you have a terms at the middle. So I'm going to divide that 10p by 2, which is 5p. So here the sequence will be, you are adding 5p to the previous terms. So 2p plus 5p, here you're going to find that the terms which is in the green circle here is 7p. Next, I'm going to solve for this sequence. So if I look at this sequence from left to right is getting bigger. So the difference between negative p and 7p will be equal to 8p, which is 7p minus negative p. So 8p divided by 2, you will find that this sequence is formed by adding 4p to the previous terms. So negative p plus 4p, you will find that this is equal to positive 3p. So last one, we're going to look at this sequence. So 3p becomes 2p, which means you are minus p to the previous term. So when 2p minus p, you will find that this term here is equal to p. Question C. So first we're going to look at this sequence from these directions. So from 7x become 12x, you are adding 5x to the previous terms. So the next terms, you are going to use the same thing. So 12x plus 5x, you're going to find that this terms here is going to be 17x. Next, we're going to use this sequence. Let's say we look at this sequence from the bottom to the top. So the difference between 17x and 5x is equal to 12x. Divide it by 2. Then you'll find that you are adding 6x to the previous terms. So 5x plus 6x is equal to 11x. And then 11x plus 6x, you're going to get 17x. Next, I'm going to look at this sequence from left to right. So it's getting bigger. So difference between 7x and 11x is equal to 4x. Divide it by 2. This sequence is formed by adding 2x to the previous terms. Therefore, the terms in the middle here will be 7x plus 2x, 9x. So last one, for this sequence. If you look at this sequence from top to the bottom, the terms is getting smaller. So from 17x to 9x, you are going to minus 8x. So when 9x minus 8x, so the terms at the bottom here will just equal to x. Questions number 4. Ashru and Jonathan are placing national flags along the school corridor from the canteen to the staff room. The distance between the first and the second flag is 5 meters. The third flag is placed 10 meters from the first flag, and this is the pattern of arrangement for the rest of the flags until the end. So determine whether the arrangement of these flags follows arithmetic progressions. Give justifications for your answer. Let this flag here is the first flag, and this one is the second flag. So the distance between these two flags here is equal to 5 meters. So the third flag here, the distance of this third flag from the first one is 10 meters, which means the distance between the second flag to the third flag will equal to 5 meters as well. So 10 meters minus 5 meters. So is this arrangement of flags follows arithmetic progression? Yes. So give justifications for your answer. So here, because the distance between two consecutive flags here, they are constant, which is 5 meters. Therefore, this is an arithmetic progression. Self-practice 5.2, questions number 1. Find the way to the finish box by choosing the correct answer. So here, this is the formula for you to find the nth terms in an arithmetic progressions. The A is the first terms and the D is the common difference. So we're going to start from the first box here. So I'm going to label the first box here as the A. So find the ninth terms in the sequence 9, 5, 1. So this sequence, the number is getting smaller. So the number 9, which is the first term, this one is the A. And if you look at here, from 9 to 5, you're going to minus 4 to the previous terms. So from 5 to 1, it is the same. So the common difference for this sequence is negative 4. So for questions A, to find the ninth terms, so we are going to use the formula that we have here. So the A is 9 plus n minus 1 is 9 minus 1 times the D, negative 4. So here will be 9 plus, here will be 8 times negative 4, which is equal to negative 32. So 9 minus 32, the answer will be equal to negative 23. So negative 23 is the answer. So next, we're going to move to this box. So I'm going to label this box as B. So given that Tn equal to 8 minus 5n, so find the fourth terms, T4. So we are going to use the formula given here to find the fourth terms being asked for this questions B. So T4 here equal to 8 minus 5. So the n here, we're going to replace it with 4. So it's going to be 8 minus 20, which is equal to negative 12. So negative 12 is here. So the next box, we're going to move to this one. So I'm going to label it as C. So given that Tn equal to 8 minus 3n. So this is the formula given. Finds the common difference D. So for question C, this one, to find the common difference D, we can use any two consecutive terms and we're going to minus them. So here I'm going to use the second terms minus the first terms. So using the formula given here, which is this one, so the second terms, I'm going to substitute the n with 2. So this one will be 8 minus 3 times 2. So this will be the second terms. I'm going to minus it with the first terms. So I'm going to substitute the formula, the n into the formula with 1. So here will be 8 minus 6, which is equal to 2. And for this one, it's going to be 8 minus 3, which is 5. So 2 minus 5, the D is equal to negative 3. So next, we're going to move to this box, which I'm going to label it as questions D. So given that T2 equal to 3 and T17 is equal to 54. So find the first term, which is the A. So from the information given, T2 is equal to 3. So to find the T2, so we're going to use the formula here. So A plus, so the n here will be 2 minus 1 D. Then we'll get the answer of 3. So if I simplify this, I'm going to get A plus D equal to 3. So this is the first information. So the second information is the 17th terms. This one is equal to 54. Now again, using this formula, so A plus 17 minus 1D, this will give you the answer of 54. So here A plus 16D equal to 54. So now let us focus on these two informations as you have two variables A and D. So we're going to solve this using the simultaneous linear equations method. So here I'm going to use the eliminations method. So I'm going to let this one as my number 1 and this one my equations number 2. As I have the A with the same value, so I'm going to use equations number 2 minus equations number 1. So A minus A, it will be cancelled. So 16D minus D, you will get 15D. 54 minus 3, you will get the answer equal to 51. So D equal to 51 divided by 15, which is equal to 3.4. That is the D. So now we want to find the A. So next I'm going to substitute the D equal to 3.4 into the equations number 1. Therefore, A plus 3.4 equal to 3. So A will equal to 3 minus 3.4, which is equal to negative 0.4. So the answer is negative 0.4. So next we're going to move to this box, which I'm going to label it as E. Given that negative 17, negative 14, negative 11 until 55 finds the number of terms. So for this sequence of arithmetic progressions, the A is the negative 17, which is the first terms, and the difference between two consecutive terms here from negative 17 to negative 14, you're going to plus 3 to the previous terms, right? So from negative 14 to negative 11, you're going to add in another 3. So here the A is negative 17 and the D will equal to positive 3. So it starts from negative 17 and with 55. So questions E, Tn, which I don't know what is how many number of terms in between negative 17 to 55, but I know it ends with 55. So Tn equal to 55. So using this formula, the A, I'm going to substitute it with negative 17 plus, I don't know what is the n, which is the number of terms, so just let it be n minus 1. The D is equal to 3. This will give you the answer of 55 of the last terms. So next, I'm going to move the negative 17 to the other side. So it will be 55 plus 17. So n minus 1 times 3 will equal to 72. So next I'm going to move the number 3 to the other side. So n minus 1 equal to 72 divided by 3. So this will give you the answer of 24. So n equal to 24 plus 1. Therefore, the n is equal to 25. So from negative 17 to 55, with the common difference of 3, you're going to have 25 terms. So the answer is 25. So next, we're going to move to this box, which I'm going to label this as my questions F. Given that A equal to 10, which is the first terms, and D, the common difference, equal to negative 4, finds T7, which is the seventh term. So this questions F is rather straightforward. So we want to find T7. Again, using this formula, the A, we're going to substitute it with 10. So the n is 7. So minus 1, the common difference is negative 4. Solve this, you'll find that T7 is equal to negative 14. So which is here. Then we already finished the box. Questions number 2. Injek Muiz starts to work in a company at a certain month. His first annual income is Rm 36,000 and the increment for the following year is Rm 1,000. So calculate A, the number of years in which Injek Muiz needs to work in order for him to receive twice his first annual income. So for questions A, the annual income of Injek Muiz actually is going to form an arithmetic progression. So the first annual income, which is the 36,000, this is the first term, which is the A. So the annual income for the second year, with an increment of 1,000, it will be 37,000. And the annual income for the third year, add in another 1,000 to the previous annual income, it will become 38,000. So it's going to form an arithmetic progression. So this 1,000 is the common difference, which is the D. So the question asking to find the number of years. So the number of years here is actually the n, the number of terms. So for Encik Muiz to receive twice his first annual incomes. So twice of his first annual income is 36,000 times 2, which is equal to 72,000. So we want to know from 36,000 with the common difference of 1,000, how many numbers of terms later on it will become 72,000. So to find the answer, Tn equal to 72,000. So using the formula A, which is the 36,000 plus n, which I don't know, so n minus 1, the D will be 1,000. So this will give you the answer of 72,000. So first, I'm going to move this 36,000 to the right hand side. So n minus 1 times 1,000 equal to 72,000 minus 36,000, which is equal to 36,000. So next, I'm going to move this 1,000 to the right hand side. So 36,000 divided by 1,000 is equal to 36. So n, which is the number of year, equal to 36 plus 1, which is 37. So Encik Muiz needs to work 37 years in order for him to receive twice of his first annual income. B, the yearly increment if his salary during the 6 years is Rm 43,500. So here the yearly increments is referred to the common difference, which is the D. So the 6 years, so this will be the salary. So for questions B, we know that T6 is equal to 43,500. So again, using the formula to find the nth term of an arithmetic progression, the A will still be the 36,000 plus here the n will be 6 minus 1. The D, which we want to find, equal to 43,500. So again, here we'll have 5D equal to 43,500 minus 36,000, which is equal to 7,500. So D equal to 7,500 divided by 5, which is equal to 1,500. So the yearly increment for questions B will be Rm 1,500 ringgit.